Welcome everyone. Today is the next video for the end of course exam prep. Let me start by apologizing. My voice is a little raspy today, but I think we'll get through it. So, as you can see here, we have Algebra Spring 2017 released item, question number 12. So in this question, we are asked, which correctly factored form of the function f of x equals 36x squared plus 15x minus 6 can be used to identify zeros? So we have a quadratic that we need to factor. Now, the key here, it says identify the zeros. That should actually place emphasis on two of these options more than the other. If you look at C and D, they have made our life a little bit easier by initially factoring out a common factor from the terms. A and B leaves the binomials a little more complex, and it doesn't help us when we want to identify zeros. So that's what we're going to start with here. And we're going to walk through this process of each step to get to the correct answer by factoring this completely. So let's take a look at this little presentation that walks us step by step. If you see at the top, we start off with f of x equals 36x squared plus 15x minus 6, and we have to factor this. Now initially we want to see if there's a greatest common factor from these three terms. Now if you look at 36x squared, 15x, negative 6, there's some very common factors in all those numbers. They actually are all multiples of 3. Now because not all terms have the variable x, we're not going to have any variable in our greatest common factor here. So we are left with just the greatest common factor 3 from only the values. Let's factor that out now. We're going to make these numbers a little bit smaller by factoring out a 3 from each of them. When you factor out 3, you're left with 12x squared plus 5x minus 2. Now we get to the real process, where we now want to factor into a product of binomials that remaining quadratic inside the parentheses. We got to remember our process. We're looking for factors of a times c that add up to b. So let's start to find those. A times c would be 12 times negative 2. So 12 times negative 2 gives us negative 24. We now want to try to find factors of negative 24. But they need to be really specific because those factors need to also add up to b, which is 5. So this is the process that we get to work through, and it's kind of an interesting process because it takes a lot of trial and error. We're going to identify these split factors. And they ask again, what two numbers multiply to equal negative 24 but add up to equal 5? So let's build this table. We're looking for things that multiply to be negative 24. Start to think of some factors. You can think of some right off the bat, maybe negative 2 times 12. Yeah, those multiply to be negative 24, but adding those values together gives you 10. So let's try some more. Maybe negative 6 times 4. Okay, again, those do multiply to be negative 24, but unfortunately those add up to be negative 2. So let's try another set. Maybe negative 8 times 3. Okay, negative 8 times 3 does multiply to be negative 24, and when I add those together I get negative 5. So I am extremely close, right? And we know when we're looking at these values, when we have negatives, we can switch the negative signs from the values to give us the same product. So not negative 8 times positive 3, but maybe 8 times negative 3. Now when you multiply those, you still get negative 24, but adding them together gives us the positive 5 we were looking for. So that tells us we have identified our split factors, our magic factors, the ones we want to work with, as 8 and negative 3. And we're going to use that on the next page. Right up in the top, it reminds us that our split factors are 8 and negative 3. We're going to continue the process. The next step asks us to use the 4 square. Now this is a process that helps us organize everything while we're factoring. And remember, we are just trying to factor 12x squared plus 5x minus 2 into a product of binomials. So let's start to fill in the 4 square. We put the first term in the upper left-hand box. We put the last term in the bottom right-hand box. And now we were looking at these split factors, right? Our split factors were 8 and negative 3, so we put those in the remaining boxes with x. Now if you combine those two terms, since they are like, notice that it gives us that 5x in the original quadratic. We're just trying to split these up, split these up so we can even factor them further. So that's filling in the 4 square. Now let's find the greatest common factor for each row and each column. So we take our filled in 4 square and we're going to look at the first column, 12x squared and negative 3x. What is the greatest common factor from those two terms? Well, greatest common factor from 12 and negative 3 is 3. Greatest common factor from x squared and x is the smaller of the two, which is just x. So putting those together, we get a greatest common factor of that column as 3x. Let's do the next column, 8x and negative 2. No variable in the second term, so we're just looking at the numbers 8 and negative 2. Greatest common factor there is just 2. Now let's look at the rows. Top row, 12x squared and 8x. Those both have multiples of 4. 12 and 8 are multiples of 4. We find the greatest common factor of x squared and x. That's just the smaller of the two again, and that's x. Put the 4 and the x together, we get 4x. Now the bottom row, we have negative 3x and negative 2. Now something interesting happened here. Both of those values are negative. So when you have negative and negative in the two boxes, the resulting greatest common factor header will be negative. So since negative 3 and negative 2 only have the greatest or the common factor of 1, the greatest common factor in this row, header, is going to be negative 1. So that is where we let these signs control the header. If you have a positive and a negative, the result will be positive. If you have a positive and a positive, the result will be positive. Now if you have a negative and a negative, that's why we have negative 1. And the best part is, we have done all the hard work now. Now we just get to take our headers and we get to put them together as our factored form. So we rewrite the quadratic in that form as a product of binomials with the greatest common factor headers. Just simply take the 4x and the negative 1 from the rows, and there it's your first binomial. Take the 3x and the 2 from the column headers, and you get your second binomial. Now, that is factoring 12x squared plus 5x minus 2. But we need to remember, we already factored out a 3 at the beginning. So our final answer here, the completely final factored form, is the 3 we took out at the beginning. The product of binomials, 4x minus 1 and 3x plus 2. And that right there is our completely final factored form of this quadratic. That will help us identify the zeros, and if we go back to the question, 3 times 4x minus 1 times 3x plus 2, we can see that the correct answer is shown right here as option C. And that is it. We talked about a lot here. We factored out a greatest common factor, then factored the remaining quadratic as a product of binomials, and now we're able to identify our zeros. That is it, everyone. Thank you for another great video. Please click that subscribe button down below, and don't forget to complete the practice question that walks through one just like this. Have a great day, everyone, and we'll see you next time.